I want to give you a little background of DARPA's current structure, some of the focus areas that we're working on, and then I really want to focus the majority of the time on talking about a particular area, a technical thrust that TTO, the office I run, that we're working on at DARPA, and that is what we call the unclassified vision for space. The reason I think it's relevant for the GEOINT, this community, is that in order to understand some of the challenges you might face in the future, I'd like to make sure you understand what are the potential platforms in the space technology area that you may be seeing and why that's relevant to what you're doing. Okay, so the mission of DARPA is unchanged since 1958. I do like to remind people that the reason the agency began was focused on deficiencies in space capabilities at that time, particularly to deal with treaty verification and weapons employment. And that was how the agency started in 1958, even though there's a lot of obviously publicity in the past about file sharing and the internet, it really started in space. The mission is unchanged, revolutionary technology that enabled breakthrough capabilities to support national security, whether that's to create strategic surprise or prevent it, one way or the other. That's what the focus is. So we are not an innovative, an evolutionary organization in terms of what we're after. It's all about the revolutionary change. And similar to what Stacy said earlier, you know, it's the high payoff, and you accept the risk to get the payoff. And if that means sometimes along the way you fail, that's just the price of really pushing as far as you can out of the box. But as I said, the mission is unchanged since 1958. Just a little history, particularly in light of public announcements over the last couple of years and analysis about the third offset strategy. The agency was actually involved in the second offset, which had to do with precision strike against, at that time, second echelon forces in the European theater. And some of the technology that came out of that was the stealth technology, HAB Blue and Tacit Blue, long-range missile capability, the Army tactical, the Advanced Tactical Missile System, ATACMS. Those types of capabilities came out of the second offset, and as part of the department's work today, we're focused on technologies looking at a third offset strategy. But you can see in the upper left the Saturn rocket, you see Global Hawk in the lower right, and at the very bottom is kind of what I want to focus on today, which is what are we doing in space, what have we done in space, and from the standpoint of the GEOINT community, why should you care? That's what I want to focus on. So the agency is, you know, there's two ways of thinking about the agency. It's very similar to what Stacy said. It's a collection of program managers, and we like to jokingly say they're most commonly connected by a travel system, because what really matters is they individually have a driving vision of something they're trying to accomplish in an environment where they have no tenure. As soon as the PM shows up, day one, and you in-process them, they get their badge, and right there at the bottom of the badge is the expiration date. And so the clock starts ticking, just like I'm looking at the clock right now. That happens all the time. What that means is there's an imperative, there's a sense of urgency. They're very impatient individuals, and that's a good thing, because if you're trying to make progress, the last thing you want is somebody sitting on their laurels. So obviously, 120 program managers. Right now, there's 6 technology offices that the agency has. I'm in charge of one of them. It's kind of the platform office. We deal with platforms in the ground, maritime, air, and space. Many of you may work with I2O, the Information Integration Office, which is focused on big data and cyber. So Strategic Technology Office has been focused on mission systems, communications, and command and control. And I think across all 6 of the DARPA offices, we work quite closely to focus on critical challenges in support of national security. So let me shift now and talk about one particular area that we work on in TTO of the 4 domains, and that is space. And I want to focus on the challenges, kind of the vision and what we see the critical parameters are, and then a few programs to give you some idea of where you can imagine the future is going to take us. So from the standpoint of challenges in space, the first thing I want to talk about is launch flexibility or inflexibility. A couple of our program managers have very lightly said, yes, we're one hurricane and one earthquake away from being out of the space business. That is that we have some geographic criticality and sensitivity to weather conditions that can inhibit our ability of getting assets in space. While that may not have been a problem from 1958 to 2000, it's a problem today. Why? Because the space environment is changing, whether it's natural or man-made, space is becoming a real-time endeavor. And when you're locked to 2 critical launch sites, or 3 with wallops, that allow you to get assets into space to support GEOINT and other capabilities, that means you're vulnerable. It also means infrastructure has been set up to make those systems highly reliable. That same infrastructure that made them reliable has also made them very expensive. And so there's a cycle that over time, if space is very, very stable and safe, that's not a problem. But when things start changing, then you get really, really worried about not having launch flexibility. And I'm going to talk about that in a program we have working on that. Second, architectures. Because those systems are very expensive, because you have fewer launches from highly reliable sites, over time, requirements and technical development has ended up resulting in satellite systems, space systems, defense space systems that are very, very expensive. And when you add more and more requirements, it takes more time. There's more certainty and reliability required because you don't want to lose that precious satellite. You're absolutely incapable of accepting launch failure or a satellite to fail on orbit. So because of that, that cycle, in addition to launch being an issue, the architectures are an issue. We're very concerned about the cost of those systems. And last but not least, space domain awareness. In the past, once again, because space was a very reliable place with fixed orbits, the things that didn't move around, we didn't worry about it as much. But now in a space between LEO, MEO, and GEO that's the size of 240,000 oceans, you have over 20,000 objects, many of them start moving around, you get worried about that. And so in terms of reliable understanding and characterization, detection, tracking, identification of objects all the way to GEO, that is a problem and something we want to solve. So before I launch into talking about these programs, there are substantial changes that have happened, commercial and otherwise, that you have to take into account. And so from the standpoint of what is DARPA, TTO particularly going to invest in terms of new capabilities we're trying to enable, we have to understand the environment around us. First, commercial access is easier than ever. You can pick up space news, you can look at space.com, any of them, and understand day by day, week by week, year by year, how things are changing in space from the standpoint of launch. New entrants are coming on board. Some of them will succeed, some of them will fail. That's just part of exploring new territory. But you have to take into account that you may have access via commercial launch platforms that we did not have in the past. So that's one thing that we take into account in TTO. Second, commercial satellite communication markets. The way most people explain it to me is once a launch provider or a satellite builder has gotten to the point where they've launched a satellite, communication satellite into geosynchronous orbit, at that point, they're literally printing money. Because once you occupy a geo-orbital slot and you set up your subscriber base on the ground, it's a very reliable, very productive, very economically lucrative endeavor. Third, wealthy visionaries. Okay, there are a lot of individuals like Elon Musk that have, and Jeff Bezos, that have tremendous visions of what they want to accomplish in space. And that's something that the US, the Defense Department, can take advantage of as long as you understand what their motivations are and what their goals are and take those into account. The way I describe it is a publicly traded entity may have different motivations than a privately held organization. You just have to understand that. Commercial startups and new entrants. Many of them you're a part of. Many of them, NGA and others, are taking advantage of the capabilities from a geospatial information standpoint. Those are proliferating. So one of the things that I think about a lot is what do we need to invest in and what do we not need to invest in because the commercial marketplace is already going to do it. We don't want to do a me too. We want to figure out what can we leverage or what is fundamentally different that we should go after that the commercial world is not. And then pick those critical areas and try and make a big, big impact. And last but not least, NASA works in the space environment, obviously, every year, and they're a robust developer of new technology. So the reason I point this out is because part of what we have to do, we meaning DARPA, is understand the trade space of different organizations that are working in space, so we figure out exactly what should we do, what should we not do, what can we leverage, and what can we partner with. So what's the vision right now that we have for robust space? First, launch. We're specifically focused in launch on time to space, and that is shrinking the time it takes to get from concept or an available satellite to launch on orbit. And I'm going to talk about the Experimental Space Plane 1 program, XS1, but the focus of that program is to get launched 10 times in 10 days, turn an asset around, a reusable space plane in 24 hours, and I'm going to talk a little more about that. Second, robotic servicing of geostationary satellites. We're thinking about completely new architectures in the geosynchronous environment. It turns out that when you send humans to the geosynchronous environment, the radiation belts and the radiation environment there is not good for humans. So the most likely mechanism to build, service, inspect an asset in GEO is going to be with a robotic spacecraft, and I'll talk about that because if we're able to succeed at that, that will fundamentally change the architectures in GEO. And last but not least, space domain awareness. We have 2 programs that we're working on in that, and fundamentally what we're after is taking advantage of the vast amount of data that is outside of the government sector, outside of the existing space surveillance network, pulling that in, mensurating the data, understanding exactly what it means to us, and then fusing that with the space surveillance data so we get essentially lower cost per byte of relevant information that a space warfighter can use to understand the situation. And then the second program, the second thing we're focused on, the space domain awareness, is understanding the space domain in real time. And the way I describe it to most military folks is the Air Force has a very good construct for Combined Air Operations Center, CAOC, so as we call it. We do not have that equivalent setup in space. We do not have the same level of training, of tools, of techniques, procedures, CONOPS, course of action visualization. None of that exists in the space environment. And that's what we're focused on, because we think if we can do that, then we will allow the space domain environment to be treated in real time, just like the air domain. Next, please. Okay, flexible, affordable access to space is the first thing I want to talk about. Next. I'm just going to tell you to go to the next chart. Thanks. The Experimental Space Plane 1 program, I kind of mentioned it earlier. So the way I encourage you to think about it is 10 and 10. 10 times in 10 days. Many of you have seen the footage from Blue Origin and the footage from SpaceX of how they're able to successfully land an asset, a suborbital first stage, land that asset back on the surface of the Earth, or in the case of SpaceX, on a barge in the ocean, going up and down. Very, very impressive accomplishment. We want to be able to do that same thing, and we want to be able to turn it around in 24 hours. If you've heard Elon's comments, he's followed up by saying all these assets, these landings, he's able to put them back in the barn and look at them, essentially. We want to go beyond that. We want to say, okay, we want to launch it again in 24 hours. There's two fundamental reasons we want to do this. Number one, from a defense or deterrence standpoint, if you have the ability to launch an asset in 24 hours, essentially on a moment's notice, then it may cause an adversary to think twice about exactly what is it in space they want to do from a threatening standpoint. So we think just having that capability could be of deterrent value. Secondly, and more importantly, we think that this will be of tremendous value to the commercial enterprise. If a commercial organization knew that if they had a shrink-wrap satellite, they could launch it and get it into space within 24 hours, it might completely change the economic architectures. It might change what's the design of the satellite, what's the technology readiness I require, what's the amount of risk I'm willing to accept. You know, obviously, I've got to be able to prove that we can do 10 times in 10 days. I also have to prove that I can do aircraft-like operations. And the way I explain it to most people is, when you got on a plane before you flew down here to Orlando, wherever you came from, if you look out the window and you look at the number of people in and around you, or in and around the plane, from luggage to maintenance to food to the pilots to the flight attendants to support personnel, everything was set up to get you on that plane and get you into the air to your destination as fast as possible. That's the business model. But in space, we have not been like that. And what we're trying to do with XS1 is start to go after these things. See if we can get a clean pad, reduce the number of humans that are at the launch pad. Turn around engines, more like you turn around aircraft engines. Now, obviously, it's not going to be a 15-minute turnaround, but if we can get a 24-hour turnaround with a reusable rocket engine, that's a big, big deal. When you start doing that, when you combine clean pad and mature propulsion systems and a 24-hour turnaround, we think you can drive the cost per launch down to on the order of $5 million for 3,000 pounds, and that's the goal we're going after. To give you an idea of where are we today, it's somewhere between $50 and $100 million if you're the prime payload and you want to go to space. So we want to drive that down by an order of magnitude, a factor of 10. We think that if once this is done, it will completely change the architecture of low Earth orbit systems and beyond, proving that you can do this suborbital space plane. Status of the program is that we're in the process of finalizing a solicitation for phase 2 and getting ready to issue it out. The particular nature of this solicitation is going to be what's called a public-private partnership, and that we at DARPA are going to fund a healthy fraction of phase 2. We're looking for capital to come in from the standpoint of the proposing vendors, and then when the demonstration is done, we expect that this will be a commercial provider. This is not necessarily going to go through the Space and Missile Center, SMC, out of Los Angeles. This is likely going to be a commercial space enterprise that we expect the Department of Defense or the intelligence community would then approach that entity in a service level agreement and say, I need you to launch this many systems for me in this period of time on this notification timeline. Next. So the technical challenges. I said we're getting ready to release the phase 2 solicitation. The first part of the program, phase 0 and phase 1, was focused on aircraft-like operations and going through the studies and analysis of reducing the number of humans at the launch pad and driving down the cost to recheck the engines. We've been looking at long-life airframes and structures, and particularly what are the advanced composites. There's been quite a bit of improvements in composites over the last 10 years, trying to take advantage of that from the standpoint of structures and materials. Now, as opposed to single-stage-to-orbit systems, this is a 2-stage-to-orbit system, and we want to show that we can get the reusable first stage, the suborbital space plane. What that means is it doesn't have to survive. The material does not have to survive going all the way to space. You're talking somewhere between Mach 3 and Mach 10, and then you bring it back down and land it. That means the thermal considerations are fundamentally different and much more relaxed, as opposed to going all the way to space and coming back and re-entering like the space shuttle used to do. Aerothermodynamics, that's another piece of the phase 1 effort that we did. Propulsion options. In contrast to past programs, XS-1 seeks to take advantage of existing or very quickly maturing propulsion systems. This was not intended to be a propulsion program. We're not intending to prove a completely new approach. And so within phase 0 and phase 1 of the program, we've been essentially maturing with 3 providers, essentially maturing their engines and going through those sorts of engineering qualifications to give ourselves confidence that in phase 2 and launch, we've got propulsion that's mature and acceptable. Operable subsystems, guidance, navigation, and control, mission planning, autonomous flight safety system. Those are all things that have been done in phase 1. And last point, low-cost upper stage options. Many of the existing commercial launch developers that have been maturing quite rapidly in the last 36 months are giving us confidence that the upper stage will be available, will be a commercial entity. So we may be able to take advantage of commercial ground launch systems for smaller satellites as the upper stage for XS-1, and that allows to emplace 3,000 pounds in an objective system. Next. Okay, so now I want to shift gears and talk about satellite servicing. Next chart, please. So the way to think about this is that DARPA's had investment over many, many years in robotics capabilities from the standpoint of ground development over the last 15 years or so. And now what we're doing is we're taking the next step beyond the ground robotics development and saying we want to place this on a satellite in a geosynchronous environment to allow us to do 4 things. Number 1, inspect systems, attach on-orbit implaceable payloads, inspect possibly fixed stuck appendages, and then reposition an asset that's lost its propulsive capability. Now, there's 2 fundamental reasons that you want to have this dexterous robotic capability in GEO. Number 1, there are many defense systems that you'd like to be able to inspect to figure out what exactly happened. You might want to reposition it in the graveyard orbit once it's at end of life. You might have an anomaly, a stuck solar array, you want to free it up, or you may want to attach a payload to it on orbit after it's been launched. So there's all kinds of capabilities that you'd like to have in the GEO environment for defense and intelligence systems. There's also an enormous number of commercial systems that you'd like to have that ability to as well. In fact, there are 10 times as many commercial systems in the GEO belt as there are defense systems. So the financial reason for doing the RSGS program is to service those commercial capabilities. Like I said earlier about XS-1, that was going to be a public-private partnership where the asset would get transferred and would become a commercial capability in the future. RSGS is going to be exactly the same thing. We issue a solicitation in the very near future. We expect that the commercial provider is going to bring the bus, the ground station, some of the integration capability, and they're going to bring the business case. What's the government going to bring? We're going to bring the robotics. We're going to bring launch. We're going to bring integration expertise as well. And once you marry those 2 things together, the concept is we would do a joint demonstration over 6 months after launch, and then at the end of the successful 6 months demo, to validate those 4 principal components there, that asset would transfer over to the commercial entity. The government robotics gets consumed in the demonstration, and it's handed over to the commercial organization along with the satellite, and they use it for the next 3 to 5 years to derive revenue and to go fix assets in the GEO environment. That is the point of the RSGS program. Next. In addition to that, there's a slight problem in the GEO environment in that if you understand the environment of robotics servicing between 2 commercial systems, a commercial robotic satellite and a commercial satellite, it turns out at present there's no what we call regulatory authority or agreement of exactly how those assets can service. In other words, how can a robotic satellite that's commercial actually operate in a cooperative fashion with another commercial entity? So in order to enable that and to free up that challenge, we're going to also form a consortium in parallel. The purpose of this RSGS or robotic consortium is to allow organizations, governments, private entities, public entities all around the world to collaborate and to talk about, okay, what are the best engineering practices? What are the recommended engineering standards? What are the procedures that you go through in the GEO environment? And the whole point of this is to take the lessons learned from RSGS and the consortium, and that will allow for insurance organizations and policy-making organizations around the world to feel that this is acceptable practice to have one commercial satellite actually touching another in a cooperative environment in the GEO belt. And so that consortium is absolutely critical. This is not typically something that DARPA does, setting up a consortium, and in this case, we thought it was absolutely necessary as an enabler to RSGS to see that future open up for us. Next. The last thing I want to talk about is real-time space domain awareness next. As I said earlier, the challenge in LEO, MEO, and GEO has changed from one of fixed orbits with two-line orbital element sets that don't change over years, and just the nature of what the warfighter or the Air Force has to do in terms of tracking assets in the LEO, MEO, and GEO environment is very static. That has now changed. And so what we're really focused on is, in our vision for space, is developing the capabilities to have real-time space domain awareness and command and control in all these environments, to treat space no different than we treat the air environment in terms of tracking capabilities. So we have two programs we're focused on this right now. One is Orbit Outlook, which is all about how do I take advantage of all sorts of non-traditional sources of information. There are individuals around the world that spend their nights with their 8-inch Cassegrain telescopes looking up at the sky and collecting data. All that data, however, is starting to be used commercially, but it's not necessarily being used by the US Air Force or other organizations. So we want to show that you can pull that data in, you can run it through a set of algorithms and databases, you can mensurate it so that its characterization in terms of its astrometric value and orbital mechanics value is something that the Air Force can utilize, and then pull that into essentially an Air Force database, show that information is of value, it drops the cost per byte of information. So that's the first thing we're doing. Next. The second program that we've recently begun is called the Hallmark program, and this is fundamentally about developing the command and control architectures to allow that space warfighter, shown in fatigues there, to do a bunch of things, to essentially assemble information of what's going on in space in real time, to prepare a visualization so that they get some idea in 4 dimensions, 3 space and 1 time, of what's going on, to develop a set of courses of action, so that when they present the commander, in this case JFCC Space, their strategic command commander, when they present he or she with the information of what's going on in space, they also can present a range of actions or courses of action. We can't do that today. And so the whole point of that is to treat space in the same sort of mature environment that we do the air domain. And so what we're doing is we've had a phase 0 demonstration completed. We've got our lessons learned. The purpose of that was to essentially baseline where we thought technically we were. Next, what we're going to go out and do is actually issue a solicitation for a service-oriented architecture, or the base layer for Hallmark. And then after that, we'll have another technical solicitation coming out looking at all the apps, whether it's mensuration or orbital elements or visualization, course of action generation. There'll be pieces of Orbit Outlook that go into it as well, and that'll be the second thing that happens. Now, to understand where this is actually going, the agreement that we have with the Air Force is to develop the test bed called Hallmark, feed this technical information into it, and then we will experiment with space warfighters over a 24 to 36 month period. At that point, it transitions to the JIC-SPOC or the J-SPOC, depending upon how those two organizations shake out in the future. Now, the reason I bring those 3 programs up to you is, number one, from the standpoint of Hallmark and Orbit Outlook, space domain awareness, whether looking up or looking down, can be seen as part of a foundation of geospatial intelligence. XS1, as an enabler to being able to change the geospatial environment and sensors and platforms, could be a huge value to you. The reason I brought RSGS up to you is that even though we're doing robotic servicing for geostationary satellites, you can imagine in the future, once that's done, 20 or 30 or 40 years hence, you can imagine the ability of using those robotics to construct extremely large apertures in the geo environment, or extremely large structures. Kind of a question that we had when we were working on RSGS and preparing that was, when a satellite goes to the geo belt, a commercial communication satellite, at its end of life, it is not brought back down. It is essentially pushed out to the graveyard belt, and there it stays for millions of years. And our point was, is there any reason that we can't build very large structures at GEO and you essentially upgrade the payloads over time, but the bus, the structure, if you will, stay there for millions of years? That's one environment where, in fact, physically it can remain. Now, whether you want it to remain, that's a different story. But the long-term platform or the long-term capability that you might imagine for geospatial intelligence is, imagine having very, very large dedicated structures in the geo environment that you've built that can be used as apertures for intelligence and geospatial information gathering. One other thing I wanted to point out that could be enabled by XS1 that I think is of value. Let's go to the next chart, please. That could be enabled by XS1 is the trade of foundational intelligence versus tactical I&W. And so it's been a legacy mission of the Intel community, NGA in particular, to prepare that foundational based layer for policymakers and analysts to understand what's going on around the world in different domains. if you have the ability to launch smaller systems in a more rapid time frame, and you worry about the time with which conflict is conducted, then you start thinking about how can I more rapidly get into the tactical I&W game. Instead of seeing databases that are updated minutes, hours, they should be updated seconds, on a second-by-second basis, understanding that from a geospatial standpoint. And I think that should be of value to you in the future. And that's it. Subject to your questions.
Thank you. That was fantastic.
Thanks.
We have more time than I thought. We have a winner. You have garnered more questions. Winner, chicken dinner. Yeah. You've garnered more questions than all of our previous, any of our previous speakers.
Oh boy.
So some of these are quick questions with quick answers, I guess. TTO director, who are the current TTO PMs focused on space?
We have a bunch of them. Let's see, Lindsay Millard and Jeremy Rayleigh's a new one joining us. Jeremy Palmer. I'm trying to think who else. John Lazinski, Josh Conway. Yeah, there's 5 or 6.
Okay.
And my deputy director, I've got a unique deputy director right now, happens to be a former astronaut. So that was one of the things I do want to point out is the RSGS program. Part of the reason we're able to very forthrightly go forward with georobotics, understanding cooperative satellite operations is Pam Miller, my deputy, actually was an astronaut that did the mission management, was the shuttle commander for the solar array unfurlment fiasco that happened with the space station and actually got fixed. So understanding zero proximity operations in space is something that's unique to very few individuals, so understanding that. And she's also very strong in space.
Great. I'm going to smush 2 questions together. Yep. DARPA's recent efforts to develop low-cost launches have failed. What makes you think XS-1 will succeed? And the second question, what is the reliability target for XS-1? Access to space is a matter of cost, time, and reliability.
Absolutely. Yeah, great question. Yeah, so we had a program that we essentially wrapped up called ELASA, Airborne Launch and Space Assist Access. So XS-1 is about a suborbital first stage. ELASA was intended to be a 100-pound launch at $1 million cost, where that was the second stage to orbit. In that case, the first stage was an F-15. Technically, the most difficult part of the program is what caused it to fail, which was we were looking at a new monopropellant. It's actually a biprop that was mixed together as nitrous oxide acetylene. And as part of the critical design review lead up, we were doing extensive engine testing and concluded at the end of that the nitrous oxide acetylene, while it had an extremely high specific impulse, it would have been great as a propellant. It was extremely unstable. At the end of it, we said it would be better as an explosive than as a rocket propellant. Its ISP was like 325, so it was high performance. If we've been able to make it work, it meant we only needed one set of plumbing in the rocket, which drove down the parasitic mass and allowed us to get payload to orbit. But like I said, it's high payoff, high risk. Sometimes things do not work. So in ELASA, you're absolutely right, so we stopped that program. It's important to note, when I talked about commercial capabilities evolving rapidly, there's a huge amount of commercial launch going on in development, and that was happening in parallel to ELASA. So even though we were not able to succeed there are a lot of commercial companies that are doing that. So why is XS-1 going to be more successful? I think from the standpoint of propulsion, I've tried to make that point that the propulsion on XS-1 relying on is much more mature. The challenge there will be, is it mature in a 24-hour turnaround? I have no doubt that we'll be able to build and fly a reusable launch vehicle. But I think the questioner correctly pointed out, are we going to be able to do it at the $5 million cost point? And are we going to be able to effectively and safely turn around in 24 hours? One of the critical parameters that's coming out in the phase 2 solicitation for XS-1 is that the requirement that before we launch this asset the first time, the vendors are going to prove to DARPA that they can actually do a ground test with the propulsion system 10 times in 10 days. That all by itself is daunting. So I think we feel pretty comfortable that we're going to burn down the risk that way.
Great. How concerned are you with space debris, particularly with robotic missions?
Oh, I'm not concerned about space debris with robotic missions. I'm concerned about space debris in general. But in the case of RSGS, I want to be very specific that we're talking about a cooperative robotic servicing. Okay, this is not uncooperative, this is cooperative robotic servicing between a robotic servicing spacecraft and a spacecraft you're servicing for which you're talking to the vendor all along. So at the moment that you start doing the robotic activities, you actually turn off the attitude and control system. As those of us that work in that community understand, the last thing in the world you want to do is take a very expensive robotic arm and have it approach and grapple onto a satellite that's under active attitude controlled station keeping. What that will do is that will completely destroy the robotic arm and both spacecraft. That's the worst thing in the world you'd want to do. So in terms of debris generation, I'm not worried about it at all, because there'll be careful inspection done, careful understanding the environment. There'll be cooperative discussions between the host spacecraft and the robotic spacecraft. This is all carefully planned in advance. So I'm not concerned about that at all.
Great. We're out of time, but I'm going to try to do a few more before they give us the hook.
Okay. All right.
If you approach industry for ideas and find a viable commercial idea that needs slight modification, what does DARPA do?
Can you say that question again? Make sure I understand it.
If you approach industry for ideas and find a viable commercial idea that needs slight modification, what does DARPA do?
Yeah, I think we do that. So there's two ways of thinking about it. One is we have an open solicitation similar to what Stacy talked about. At least within TTO, we have an open solicitation where we go through an abstract, a white paper, and then a full proposal. So if industry comes to us with an idea that comes in through the open office broad agency announcement, we can iterate based on what industry is proposing to us. Within solicitations like XS1 or RSGS, we've actually made sure that we've got the latitude for industry to give us a range of options. There is no one design for a suborbital space plane. There are ranges of what the three vendors that have been working on Phase 0 and Phase 1 are doing. There's also a whole range of options that the commercial sector may opt to bring in. In the case of RSGS, the same thing. There are a range of trades that folks have talked about what they would like to bring to us in terms of a satellite bus to put the robotic arms onto. There are a range of cases of what they want to do from a business standpoint. So we've obviously got the flexibility in the solicitation we're issuing to allow a range of considerations to come in.
Since it's GEOINT, I'm going to ask a question with high-resolution maps in it. Autonomous vehicles are closer to reality than thanks to DARPA challenges. Most industry is relying on high-resolution maps for a priori knowledge to tackle the problem. What should be the role of the GEOINT community in matching industry progress? Should government start collecting the maps or expect fully autonomous vehicles, et cetera, et cetera?
Wow, loaded question. I think there's a bunch in there. Let me unpack part of that. I think I was at AUVSI, at Exponential, which is the AUVSI experience now, 2 weeks ago. And where that community is now with autonomous vehicles and autonomous sensors to support navigation, compared to what it was 10 years ago, is phenomenal. It's now a commodity. Price points are dropping. It's a robust industry base that's all competing, which is kind of what you like to see. So I think from the autonomous vehicle standpoint, the prices are rapidly coming down for GPS, INS, LiDAR systems, EOS systems, optic flow, all those things are coming down. Now, if I had to say something that the geospatial community ought to think about is if GPS is gone completely, just completely gone, how would what's the basis of the geospatial information and your sensors to collect that information? Because you would still need that. You may have your base layer from the past, but in real-time information, if you're collecting with sensors that no longer have GPS aided, that could be a real challenge. So I think that's something that I would encourage you to think about.
Okay, I'm going to try to squeeze these out. So in your list of changes, you didn't mention foreign government and foreign commercial space activities.
No.
Can you share some thoughts on these challenges?
Yeah, well, I'm not going to talk about foreign space activities. It's a rich trade space around the world. What I will say is, this is an important point, is that in the past, all the evolution that the geospatial community has done that has benefited the U.S. warfighter was a unique advantage they have. I think the U.S. warfighters now realize that all this information is global and that they should assume their adversary have all that same information looking at them. And I think that's something that we're trying to get the U.S. warfighter to understand that now. In the past, best sensors, best capability, best exploitation, and so they felt they had a unique advantage of understanding what the adversary might be thinking about and what they might be seeing. That's all changed. Just assume the adversary sees you every bit as much as you see them, because there is a proliferation of sensors that are providing geospatial information around the world.
DARPA's initiative to have a unit in Silicon Valley and interact with the units in Silicon Valley?
So I think the Department of Defense, DIUX, that's reporting. I guess the reports are just going to report to the Secretary of Defense directly. It was AT&L before. I think it may be changing. I'm not sure the exact situation. We interact with DIUX. At present, we don't have any specific agreements with them. But I think the way I would phrase it is that DARPA, we work with the ecosystem of all defense organizations doing research development.
Great. And the last question is, and I think it relates outside of TTO,
sure.
But there's a term that's knocked around in these circles for years of the cyber location nexus, kind of the mashup between virtual and the physical worlds, Internet of Things. We hear a lot about that. How does that relate to TTO, or is it completely outside?
No, I think it's absolutely critical. So the nexus of most of the work within DARPA done in the cyber domain at kind of the fundamental phenomenology, formal methods, is within I2O, information integration. The merging of cyber and physical from the standpoint of protection of systems is throughout the entire agency. And I will just say that we've got a bunch of platforms. On every single one of these platforms, and when the solicitation for RSGS comes out, if you're interested, you'll see it in the solicitation. We're very concerned with all of our platforms at a fundamental level about cybersecurity. Because you want to make sure that when you have an autonomous system, whether it's an autonomous vehicle or aircraft or spacecraft, you'd like to have some confidence that it's secure and that it's going to do what you think when you think it, and how exactly you want it to perform. Not just because you want it to be reliable in accordance with the commands or the expectations you have, but that nothing nefarious is happening with it as well. So I think cyber physical, some might say it's proliferated across the whole agency with a fundamental basic science and S&T and what are the new methods and capabilities from an autonomous protection standpoint. That's more what I2O has been working on.
Well, Dr. Tousley, I want to party with you. So everyone, please give him a round of applause. Thanks for coming out.